Okay, today just going to do one section in there in this review video because there's a fair number of problems. I don't want to have a video that's 20 some minutes long. So one section, 1.3. And the first problem we're going to look at is solve x times 3x minus 1 minus 2 equals 8 by factoring. Now you might say, well, it's already factored. Well, no, it's not factored. To solve by factoring, you have to get all the terms on one side, multiply out everything, get it in the form x squared plus bx plus c equals 0, and then factor it. So do all that, then try and factor it, and then we'll go from there. So your first steps here should be to multiply out, subtract 8 from both sides, combine like terms, and you get 3x squared minus x minus 10 equals 0. Now it's in that form where everything's on one side. Now we can factor it. And I know some of you, a lot of you still like that factoring by grouping method, but I'm telling you for a lot of these problems, it's easier just to figure out what possibility works. In this case, we have to have 3x and x as our leading terms. We either put a 10 and a 1 or a 5 and a 2. If we put a 10 anywhere in here, we get too many x's. So we have to put a 5 or a 2. The 5 can't go here because we'll multiply by 3 and get too many x's. So the 5 has to go here. The 2 has to go there. Now we just figure out which plus and which minus goes where. We want minus 1x, so we're going to want a minus 6x, a plus 5x. And there's the factorization. So for a lot of these, doing it this way is an easier way to factor. So now your next step is apply this zero product rule, which says let each factor equal 0 and solve. And that will give you your solution. So why don't you do that if you haven't done that already? So we let each of those factors equal 0 and solve. In one case, we get x equal negative 5/3. In the other case, we just get x equal 2. Okay, our next problem here is solve 2x minus 5 quantity squared minus 2 equal 9 by extracting square roots. And that is definitely the easiest method of solving this equation, because we've got this quantity squared. It's not quite by itself on one side of equals. So before you can extract square roots, you have to add 2 to both sides. And that gives you 2x minus 5 quantity squared equals 11. And now you extract square roots. Now what that amounts to is square rooting both sides. With one twist, when we square root, we have to account for the two answers, the plus and the minus, both positive and negative square root of 11. So that gives us, that accounts for the two things that square out to the same thing as 2x minus 5 quantity squared. So you have to remember that plus and minus when you're extracting square roots. And now you just solve this equation for x. Add 5, add 5. I like to put the 5 before the plus and minus. So 2x equal 5 plus or minus square root of 11. And then divide by 2, both sides. And we have our answer. And if you would use the quadratic formula, you would have to plug these large numbers and square it out. And you'd have to get out a calculator. And you'd get an answer that wouldn't even look like this. You'd have to simplify it a bunch of times to get it to look like this. So this is definitely the best method here of solving this equation. Okay, in our next problem, we're going to solve 3x squared plus 6x minus 2 equals 0 by completing the square. Now, completing the square is a step-by-step process. You should memorize the first 2 steps. So your first 2 steps, isolate the x squared and x terms. So move that 2 to the other side. And the second step is divide by the x squared coefficient, which is 3. Now, when we divide by 3, we have to divide all the terms by 3, Because what we're really doing is multiplying both sides by a third. And when you multiply the left side by a third, you're distributing that third. So all the terms are multiplied. So that gives us x squared plus 2x equals 2/3. Your next step is to add this special amount to both sides that's going to make the left side a perfect square. Now the special amount, if you can try to remember this, we take half of the coefficient on x, which is 2. 1/2 of 2 is 1. Then we square that result. 1 squared is 1. That's our special amount. We add that to both sides. Now by doing that, we have a trinomial on the left side that factors into a perfect square. It always does. Now you might want to, in this step, combine 2/3 and 1. 1 is 3/3, so that adds up to 5/3. Might want to do that right away. Our next step is factor. And that left side factors as x plus 1 quantity squared equals our 5/3. Then last, extract square roots. So now we have a problem that's like the previous problem. That can be solved by extracting square roots. So we get x plus 1 equal plus or minus square root of 5/3. And then solve that. X equals -1 plus or minus square root 5/3. Now as you do this problem, maybe you use some calculator to check it and you say, wait, that doesn't look like the answer they got. Well, we can rewrite that answer by rationalizing that denominator. Multiply by square root of 3 over square root of 3 gives us square root of 15 over 3. Then rewrite -1 as -3 over 3. And then we can combine those two answers, or two fractions, into -3 plus or minus square root of 15 over 3. So like if you put this on some online calculator, they'll give you that answer and you're going, wait, did I do this right? I got that answer down here. Well, it can simplify into that answer. And you should know how to go back and forth from one answer to the other. That's important. Okay, in the next problem, solve 3x squared minus 0.21x minus 1 equals 0 with the quadratic formula. And let's round to 2 places, 2 decimal places. So we just plug all of those values a, b, c into the quadratic formula. So our quadratic formula, -b plus or minus the square root of b squared minus 4ac all over 2a. We plug those coefficients in. -0.21 for b, 3 for a, and -1 for c. And if you notice here for the 0.21, I just left off the negative sign because we're squaring it. It'll disappear. Getting all our signs correctly, we get 0.21 plus or minus the square root of 12.0441. And now on your calculator, to get that square root, you've got 12.0441. You multiply all this stuff out. 0.21 squared plus 12. And okay, now I want to square root it after the fact. Well, you can do that by raising it to the 0.5 power. You can see this. That's the half power. That's the square root. Remember, the 1/2 power is the square root. So that evaluates our radical. And then add 0.21, divide by 6 equals, and I get 0.6134. So it rounds to 0.61. rounded off. And then the other answer, in a like manner, is negative 0.54. But remember that trick. Square root of something is the same as the 1/2 or the 0.5 power of that thing. Okay, our next problem, solve 2x times x minus 1 equal 4x minus 5 by any method. Now, generally for quadratic equations, unless they're in the form where you can extract square roots, you always want to write them in the form ax squared plus bx plus c equals 0 and then go from there. Either factor them or use the quadratic formula or complete the square if you feel like doing that. But that's what you always want to do unless they're already in that special form where you can square root both sides. So that's what you want to do. Get everything on one side and then go from there. So we distribute out and then subtract 4x from both sides and add 5 to both sides, and we get the equation 2x squared minus 6x plus 5 equals 0. Now we see, can we factor that? It almost looks like it will factor, but not quite. We can try and try. If it was just a little bit different, we could factor it. But with that 2 in front of there, we can't factor it. So then we have to go to the quadratic formula. So you plug into the quadratic formula and then simplify, and you get 6 plus or minus. Square root of 36 minus 40 is negative 4. So here we see right away it couldn't have factored because we got a square root of a negative. Now from section P6 we've learned that we can write that as I square roots of 4. The I gives us a way of writing this answer. And then that square root of 4 simplifies to 2. So we get 6 plus or minus 2i over 4. Now, if you're doing this problem in WebAssign, they definitely won't have the answer written that way. They will simplify. And the way we simplify that fraction, don't do this incorrectly. Don't cancel a 2 out of 6 and 4 and leave the 2i alone. The way to do this correctly, I have this up in blue here in the corner. Factor the 2 out of the numerator. Then cancel that 2 with the 4. And that gives you 3 plus or minus I over 2, which you could also write 3 halves plus or minus 1/2 I if you wanted the standard complex standard forms. So know how to go back and forth and simplify these answers. Correctly, that is. Okay, in our last problem, I'm going to look at a problem similar to what was given as your last WebAssign problem. A box is made out of this x by x square cardboard piece with 2-inch squares cut out of each corner. The sides are folded up, and you get this resulting box. When you fold up the sides, looks something like that, with a volume of 210 cubic inches. What does x equal? Rounded to one place. So to do this, we use the formula volume equal length times width times height of a box. Since our cardboard is x and we're taking 2 inches and another 2 inches, this side from here to here is actually x minus 4. So actually our box has a length of x minus 4 and a width of x minus 4 and a height of 2 when we fold up the sides. So that's what we fill in to for our variables area, and we get the equation 210 equals x minus 4 times x minus 4 times 2. It's a quadratic equation that we can then solve. So why don't you try solving this? When you get your answers, round them to 1 decimal place. So when you multiply all that stuff out, I multiplied the 2x minus 4's together, then multiplied through by 2, and then subtracted 210 from both sides. I got 0 equal 2x squared minus 68, or minus 16x minus 178. Now we can solve that. Now what I would suggest, there's a common factor of 2, and you should always factor that common factor out first. And when you do that, you get 0 equal 2 times x squared minus 8x minus 89. Now we can divide both sides by 2. And let me write this so we can see it. There we go. So continuing up at the top here, when we divide both sides by that 2, it disappears. So we have the simpler equation, 0 equal x squared minus 8x minus 89. And I can tell you that's not going to factor. And so that leaves completing the square or using the quadratic formula. And we're wanting a decimal answer here, so it's probably a best idea to just use the quadratic formula. So when we plug into the quadratic formula and simplify, we get x equal 8 plus or minus the square root of 420 over 2. Now, one of those answers will be negative, but we can't have a negative length. So actually, the only answer is going to be the plus answer. You can throw the negative one away. So take the half power of 420, add it to 8, and divide by 2, and you should get 14.246, which gives us more than enough decimal places. So if we're rounding it to 1 decimal place, 14.2, in this case, inches. Now, if you actually then take 4 away from that, you get 10.2 times 10.2 and divide by or multiply by 2, you only get a volume of a little over 208, which is not 210. The reason it's not 210 is we rounded so severely here. That's what the WebAssign asks for, is to the tenths. I would think you'd want to round at least to the 100th, you know, as a practical matter. 14.25 gets you a lot closer to 210 when you check your answer. So that's it for the 1.3 review.